Welcome to qnawire.
Okay, so we're doing chapter 18, problem 31. So the problem says if air pressure at a particular place in the mountains is 0.75 atmospheres, estimate the temperature at which water boils. So at boiling temperature, we know that P of the air equals P sat. So let's first convert this to pascals because that's going to be an easier unit for us to use. So this, if we convert to pascals, is 7.6 times 10 to the 4 pascals. And now we need to figure out what temperature corresponds to a saturation pressure of this. So we need to look at table 18.2 at page 562 in the book. And we should see at 90 degrees Celsius, the Psat is 7.01 times 10 to the 4 pascals. And at 100 degrees Celsius, it is 1.01 times 10 to the 5th pascals. So we know this must correspond to some value in between there. But we can estimate this from a linear interpolation. So what that means is we basically, if we can imagine these points plotted on a pressure versus time plot here, this being the first one, so this being 7.01 at 90, and this being 100, and this being 10.01. So now we just assume that there's a line between here, and then we want to find where this is 7.0 or 7.6. Right? So we want to figure out what value this temperature is. So this might seem kind of challenging at first, but it's actually simpler than you thought. So we actually can just take the T final minus T initial here and subtract off the delta pressure. And what that gives us is the slope for this line. So this becomes 100 minus 90 over 10.1 minus 7.01. This is 10.01, sorry. No, that is 10.1. Yep, 10.1, okay. And that is times 10 to the 4th pascals. So then we can see that this becomes 3.236, and the units here we have degrees Celsius over pascals. And this is, times 10 to the negative 4. So this is our slope value, right? So if this is our slope and we can extrapolate to the y-intercept being 0, then we easily can figure out what this is. So if we want to find the temperature at P equaling 7.6 times 10 to the 4 pascals, this is given as our original here. We can start with the first place, so 90 degrees. And now we add on the difference in P's, so 7.6 minus 7.1, all times 10 to the 4 pascals, and then times our slope value, and that was 3.236 times 10 to the negative 4. And this is degrees Celsius over pascals. So we can see here that our pascals will cancel, and we're left with 90 degrees Celsius plus this value, which we calculate to be 1.9 degrees Celsius. And this comes out to be 91.9 degrees Celsius, or roughly 92 degrees. And that's where water boils at that on the mountains. Sweet, we got there.